Okay, here's our second example, and it looks at another exponential function with other transformations applied to it. So for the exponential function, y equals negative 2 times 4 to the exponent 2x plus 4, and then minus 3. Now, again, remember that we need to figure out what the base function is first, and the base function has the exponents applied to it. So right away I can see that 4 is the base value that has all the exponents being applied to it. So this 4 here that I've highlighted in red is actually the base function that we're going to be looking at, y equals 4 to the exponent x. Okay, so I can write that down right away. So the base is y equals 4 to the exponent x. Now all the other numbers, the negative 2 at the front, the 2x plus 4 in the exponent, and the minus 3 at the end, all of those numbers represent transformations that are being applied to y equals 4 to the exponent x. Okay? The other piece of information I can write right away is the horizontal asymptote. So, in terms of the horizontal asymptote, remember horizontal asymptotes are affected by a vertical shift up or down. So I noticed that at the end, there's a minus 3, which indicates the graph has been shifted down 3 units. So the horizontal asymptote is moving from 0 down to negative 3. So the horizontal asymptote is at y equals negative 3. Now before I write down my key points, I want to look at the function and make sure that it's in the proper form that I need it to be in. And right away I recognize that it's actually not, because my horizontal transformations are not in factored form. This should say y equals negative 2 bracket, and I'm going to highlight the base function, so 4, and the exponent part here should be in factored form, and I'm going to rewrite it as 2 times x plus 2, and then minus 3 at the end. Okay, so the reason why we need to make sure that the horizontal transformations are in factored form is just so that our horizontal shift is where it's supposed to be. So here it looks like it's shifting to the left 4, even though it's actually shifting to the left only 2. Okay, so the negative 2 at the front, the 2 in the numerator, and the exponent, and the other 2 in the exponent, and the minus 3 at the end are all the different transformations that are being applied to y equals 4 to the exponent x. Now I can come up with my key points. So x and y equals 4 to the exponent x. And the x values that I'm going to use again are a point to the left of the y-axis, a point on the y-axis, and then a point to the right of the y-axis. And in order to solve for these y values, I'm going to look at 4 to the exponent 0. Sorry, not 0. I apologize for that. 4 to the exponent, negative 1. Then I'm going to look at 4 to the exponent 0, and then I'm going to look at 4 to the exponent 1. Okay? So 4 to the exponent negative 1, so if you remember your negative exponents, this is the same thing as 1 over 4 to a positive exponent. So that's like 1 over 4 to the exponent 1, which I know is 1 over 4, or 0.25. And then the second one, 4 to exponent 0 is equal to 1, and then 4 to exponent 1 is equal to 4. So there's my key points. This time my base function is different. That's why my key points are also different. So your key points depend on what your base exponential function is. Now let's look at the different transformations that are going to be applied to this to figure out our mapping formulas. And so let's start by looking at the x values. So horizontal transformations appear in the exponent part. So the first number here is actually a horizontal compression by a factor of a half. And the second number is actually a horizontal shift to the left 2. So 1/2 x minus 2. And then let's look at our y values. We have a negative 2 at the front. We have a negative 3 at the end, which means the graph is being reflected and stretched and then shifted down 3. So we can solve for our corresponding values of x and y using the mapping formulas. So 1/2 times negative 1 is negative 1/2. Minus 2 is negative 2.5. Half of 0 is 0. Minus 2 is minus 2. Half of 1 is 1/2. Minus 2 is negative 1.5. Okay, for our y values, negative 2 times a quarter, that's negative a half, minus 3 is negative 3.5. Negative 2 times 1 is negative 2, minus 3 is negative 5. And negative 2 times 4 is negative 8, minus 3 is negative 11. And what I want you to notice now is that our values have changed slightly. And you'll notice that all our values of y are lower than our horizontal asymptote at y equals negative 3. Now, why did that happen? Why are all the y values lower than the value of the horizontal asymptote? Let's take a look at our transformations. This transformation here, which is a vertical reflection in the x-axis, what that's caused the graph to look like is it's actually changed the direction in which the graph moves. So normally our graph goes up and to the right. Or it goes down and to the right. But as soon as you reflect the graph along the y-axis, what ends up happening is the graph will either look like this or it'll look like this. Okay, and so all the values of y end up going below the horizontal asymptote. So vertical reflection ends up causing the function, the actual graph of the function, to go below the asymptote. And so that's essentially why the values of y that we have here are lower than the horizontal asymptote that we have here.